So in this video, we'll be examining the relative atomic mass, relative molecular mass, moles, and molar mass. So those are the things we'll be examining in this video. So now, let me start with the relative atomic mass. We are talking of the relative atomic mass of an element. We are talking of mass of one atom of that element. Mass of one atom of that element as measured by the mass spectrometer. Are you getting it? So normally they used to weigh they use carbon 12 as the standard to determine the relative atomic mass of elements. So but accurately it has been measured with the aid of mass spectrometer. So that's that. So for example now, hydrogen. Now look at hydrogen. RAM, relative atomic mass, permit me, of hydrogen, that's 1.008 gram. 1.008, okay, and no gram here, 1.008. So approximately is 1. That's the idea of mass spectrometer. Now to talk of oxygen. Now oxygen atom. Don't forget we are dealing with atom now. So it was measured from the mass spectrometer 15. That's 15.9. Okay, 994. So approximately it is 16. So that's why you see that's relative atomic mass of oxygen. So and so on like that. So that's what relative atomic mass is. So we shouldn't waste time on that. So now, what is relative molecular mass? What is the relative molecular mass of a relative molecular mass? Now it applies to a compound. We're talking of relative atomic mass. It applies only to an atom. That's all. So but for a compound, let's say for a compound like, now let's talk of a relative molecular mass. Now look at the compound like CaCO3. Now look here, this is a compound CaCO3. Now what's the relative molecular mass? So if we don't want to stress ourselves further, the simple definition of relative molecular mass is the relative molecular mass of a compound is the sum of its relative atomic masses of each of its atom. Sum of the relative atomic mass of each of its atom. Hope you are getting me. Okay, let me read it off from here. It is the sum of the relative atomic mass of each element in a compound. So that's it. So now look at, for example, CaCO3. What's the relative molecular mass? Now look at Ca. Look at this calcium, this carbon, this oxygen. Are you getting it? Now look here. Now look at calcium. Calcium has atomic number of that relative atomic mass of 20, I think. Okay, 40. Okay, that's 40. Don't let me guess. Now look at it. Since we have only one calcium here, so let's say 1 times 40. Let's bracket it. So plus, look at carbon. It has RAM of 12. Are you getting it? So now when you put it, because we have only one carbon here, let's put 1 times 12. So here then plus again this oxygen. Look at from here now, it has RAM of 16. So that will be 3 times 16. So when you put together, when you add, what you have is 100. So can you see what you have is 100? So this is the relative molecular mass of calcium trioxocarbonate, CaCO3. So there's that. So we'll move forward. Now let's talk of a mole. We are moving gradually. So when you're talking of a mole, it is defined as the amount of a substance which contains the same number of particles as there are atoms in exactly 12 grams of carbon 12. Are you getting it? Now carbon 12 is used as standard. Are you getting it? Carbon 12 is used as standard. Now they now define the mole as the amount of a substance which contains the same number of particles. So when you're talking of the particles, you're talking of atoms, molecules, and ions, as there are atoms in exactly 12 grams of carbon 12. Now look at it, mole. Now they said it the amount of a solid which contains the same number of particles as the atoms in 12 grams of carbon 12. Now, do you know when the modern chemists when they weigh 12 grams of carbon 12, they try to determine the number of atoms it contains. So they discovered that it contains 6.02 times 10 raised to the power 23 atoms. So I think you are following. It contains 6.02 times 10 raised to the power 23 atoms. So now, when you're talking of, when we relate it to a mole, when we relate it to a mole, so the amount of a substance, for example, now let's say for example oxygen, for example. So when they weigh oxygen, so the mass of that oxygen that will contain this amount, this is 6.02 times 10 to the power 23 atoms. Are you getting it? So that would be the mole of that oxygen. Are you getting it? That would be the mole of that oxygen. So now the same thing applies to other elements too, like nitrogen. Now the mass of nitrogen they will weigh that will contain this same atom that is present in carbon 12. This is the atom present in carbon 12. So the mass of it they weigh that will contain the same amount present in carbon 12. So that will be the mole of the nitrogen. Are you getting what I'm saying? So I think you should be able to get that. Now I want to give you some important relations that will help you. So now when you're talking of the mole of a substance, so 1 mole of a substance is equivalent, now this is an equivalent sign, to 6.02 times 10 raised to the power 23 1 mole, 23 atoms, molecules, ions. So now let's say 1 mole of a compound. Now a compound, for example, contains 6.02 times 10 to the power 23 atoms. So 1 mole of an element, it contains 6.02 times 10 to the power 23 atoms. So it goes like that. So now the same way, 1 mole of a molecule is 1 mole of a molecule is equivalent to the relative molecular mass. Now look at the CaCO3 we did here. So 1 mole of CaCO3 is equivalent to the 100 we have here. Are you getting? That's the relative molecular mass. So 1 mole of molecule is equivalent to the relative molecular mass. So the same way, let me look for another relation. 1 mole of an atom. Now 1 mole of an atom is equivalent to the relative atomic mass. Are you getting it? So for example, now relative atomic mass of oxygen is 16. Are you getting it? So 1 mole of atom will contain 16 grams. Are you getting it? So that's it. So take note of it, because you will be needing these relations in subsequent calculations, and most of the calculations in chemistry. So it's very important. That was why I brought them out for you. So let's move forward. We are moving gradually. So now during chemical reactions, do you know what happens? Reactants and products are expressed in mole. Now look at it. Let me give you the reaction for water to be formed. Look at 2H2 gas plus O2. Yes. So yield 2H2O. So this is a balanced chemical reaction. Now reactants and products are expressed in mole during chemical reaction. They are expressed in mole. Now look at it. Let's use the mole concept here. So now look, what you have here is, look at this hydrogen here. Don't forget I've told you we identify atoms, molecule, and ion. So now this, when you have H, this hydrogen atom. So let's talk about hydrogen first. These 2 moles of hydrogen atoms, 2 moles of hydrogen, 2 moles of hydrogen molecules. I think you will agree with me. Now for molecules to be formed, don't forget that we need to have 2 or more atoms. Now look at it. We have, instead of having H alone, now we're having H2. So this is a molecule. Now this two moles of hydrogen molecules. So the same way goes to so atom. Now look at, let's count the atoms. This hydrogen, this 1, 2, this hydrogen atom, 2 hydrogen atom, 1, 2 again. Now times 2, that's 4. So this one will be 4 moles of hydrogen atoms. Are you getting it? So now that's that. So now let's move again. Let's try to oxygen. 1 mole of oxygen, what? That should be molecule. I think you can guess. Molecule. So because that was why we identified molecule the other time. So now back to atoms. That will be 2 moles of oxygen atom. So that's that. So the same thing goes like that. So that's that. So now let's move. Now let's move to molar mass. When talking of molar mass of a substance, what exactly are you talking of? Molar mass of a substance can simply be defined as the mass of 1 mole of that substance. The mass of 1 mole of that substance. That's the molar mass of that substance, expressed in gram. Expressed in gram. So now look at it now. For example, the other time I used CaCO3. Now the molar mass of CaCO3. Now look here, CaCO3. The molar mass is 100 gram per mole. Now 1 mole of CO3 is equivalent to 100. So mass of 1 mole of that substance is 100 grams. So that's the definition of molar mass. So thank you. So don't forget to subscribe. Bye.